Well, hello guys, it's Greg here. I'm a little excited. I can't believe the weather has finally broken and the clouds are starting to clear out here. I'm going to make a little exposure adjustment there because the clouds have been going in and out for the last 45 minutes or so. And I'm just really excited. This is my first live stream since about this time last year, so it's going to probably be a little rusty here, but you're looking at a live shot of the moon. The penumbral phase of the moon, which is a part that's like barely visible, has already started. Let me see. Let me put some crosshairs on the screen here. Let's see. That's not going to work. Crosshairs there. Nope. There we go. Let's close that. So the penumbral phase has already started. So the eclipse is going to come up from the bottom of the field of view here and slowly eat away at the moon here. And you can kind of notice that like this bottom portion of the moon here is a little bit darker than like over here. Sometimes it's kind of hard to tell because of the clouds going in and out, but it is definitely the penumbral phase of the eclipse has already started. The umbral phase is the part that is really the darkest part of the eclipse, and so once that starts, that's scheduled to start at about 9 minutes after 10 local time here. So we've got about 38 minutes or so. We'll be able to really start seeing a bite being taken out of the bottom of the moon here. It's been cloudy like just right up until the last few minutes, so I have not even had a chance really to do a good focus yet. I think I'm gonna wait probably another 10 minutes or so. The chat is open if you want to chime in there. I see my buddy UFO Joe has already chimed in. He's first on the list there. You should have said first, Joe, instead of clear skies. But yeah, hoping for clear skies tonight. It's going to be a really good eclipse. I've got quite a few things to share, and I might as well get to some of this before we get too deep into the eclipse here. I've got a little animation that was created by NASA that kind of shows the phases that the moon is going to go through tonight. So this outer ring here is the penumbral phase. So you'll see the moon's going to come through here, and really when the moon is in this penumbral part of the shadow, it's barely even noticeable. Like, I don't think the slight dimming is even going to show up on this video here. But the partial starts right there, and that's when you'll really start seeing a chunk of the moon disappearing in the shadow there. The deepest part of the eclipse, max eclipse, is going to be at 11:58. Totality begins at 11:26 and 11:59. Sorry. So that'll be its absolute darkest part. So if you're going to go outside, plus or minus 10 minutes around midnight tonight would be a great time to step outside and look at the moon. Or if you just want to see the part of the moon when it's first starting to go into the shadow. I'm not outside. I'm comfortably in my living room here. I'll go here in a second to, let's see, what do I want to go to? This camera here. So here's a live shot of my telescope out in my observatory in the backyard. And as you can see by the way the telescope is pointing, the moon is just rising over the roof of my house right now. But we're seeing stars, so that's a good sign. That means it's starting to clear up out there. If you got any questions, put them in the comments there, and I will try to get to them. Yes, Joe, you do get a prize. You do get a prize. Let's see. Let's switch back to the live feed here. going to be a long night. I'm not going to stream all the way till the very end of the penumbral phase because it's going to be about as boring as what we're looking at right now. I'll go all the way until the partial eclipse passes, which partial ends at 1:47, so I'll probably be signing off around 2 a.m. So that's about 4.5 hours from now. I am not going to be able to talk to you guys for 4.5 hours, so at some point in time, I'm going to just shut my mouth and pump the music up and let you guys listen to the eclipse or listen to the music I've got. And definitely seeing some darkening along the bottom edge here. And I think the clouds have finally cleared out. I'm going to stand up and look out my window here. Yeah, we've got nothing but clear skies right now, so that's good. All right. I think what I want to do now is I want to do a real quick focus check. So I'm going to zoom in on this to 100% and go over to this edge here. This dark crater here is called Plato. So, and it's because of the contrast with the surrounding area there, it makes it kind of easy for me to easier from focus. Beverly, hi Beverly, welcome to the party. I am in Henderson, Nevada. It's a suburb of Las Vegas. So that's where I'm at. West Coast Pacific time zone. Where are you at? Let's see. 11,200. See if that's the right direction, if this gets a little sharper. I think that might be a little bit better. So you'll notice on the console here. So this is the current position of the focuser, and as the evening cools off, that will change a little bit. I'll have to focus about every 30 to 45 minutes because the telescope actually shrinks or expands a little bit depending on the temperature. So focus position changes. Rapid City, South Dakota. Well, okay, so I know my buddy UFO Joe is here in Henderson, close to where I'm at. So you currently have the prize for the furthest distance viewer. I think the last time we did a lunar eclipse live stream, we had somebody from the UK. So you might get beat out at some point in time tonight. Let's go back to... turn the crosshairs off and go back to showing the full disk of the moon here. So you'll notice on the console here where my cursor's at, there's a up, down, left, right button. So this actually kind of nudges the telescope. The telescope normally would be tracking perfect and I would never have to touch these buttons. But I was out in my observatory earlier today changing the camera out. I wanted to put the color camera on so that we could see the colors during totality. And I bumped the mount, so I think I knocked my polar alignment out just a little bit. Oh, we're going to get UFO peeps in here tonight. Okay, cool, Joe. As long as they don't go crazy and tell me that's a flat disc up there. Okay? I'm good with that. Let's see. And when you see it, when you see the image like just really like undulating like that, like it looks like a wet noodle just kind of wobbling around, that's because the wind is blowing pretty hard outside. We had 15-20 mile an hour winds earlier. And I'm just kind of getting a feel for which direction my arrows go. All right, so the down arrow kind of goes up towards the 10 o'clock position. So that means 4 o'clock, 3 o'clock there, or 4 or 5 o'clock that way. because the camera's rotated to sort of show a correct orientation, as though if you were outside like right now and looking at the moon, just looking straight up at the moon, you would see this dark circular patch. This is Mare Crisium, I think, the Sea of Crisis, and it is basically pointing straight up if you're looking directly towards the moon right now. Yeah, there's a lot of people around the country that are under cloud cover tonight. I honestly was thinking that my whole live stream was going to be canceled due to clouds. It rained here today, which is very, very rare. I am setting an alarm on my phone here for 10:08 to remind me that the partial is about ready to start. 22:08. Okay, so that's 27 minutes. 27 minutes from now is when the partial phase starts. John H. I'm guessing I know who that H is. Thanks, John. Glad you could join me here for a little while. I got really lucky just as the moon was... I had timed my live stream to start about 20-30 minutes after the moon came over the roof of my house, and right about the time that it cleared the roof of my house is when I was first able to actually see it through the clouds. So we're getting kind of lucky here, but as you can see by the wobbling, that's the wind just kind of like pushing my scope around, because only the top 2 or 3 feet of the telescope is sticking above the walls here. I'll go to that shot there is kind of a live shot from inside the observatory. This camera point of view is actually really low. It's about even with halfway between the top of the leg and the bottom of the leg there, pointing up, so I can kind of keep an eye on the sky too. So we've got a little bit of cloud cover. We've got a bright star there. I'm guessing that might be... I'm not going to guess because I don't see enough stars around it to be able to figure out what that is. But anyway, so I had a few photos that I could share of previous eclipses. So this is one of my composites from an eclipse, and I don't remember the date of this eclipse. But hi, Stefan Rourke. Welcome to the live stream here. This is my first time live streaming in almost 1 year, so a little rusty, but I'll try to answer questions. I've got a separate sidecar monitor set up here next to my computer, so I can keep an eye on the chat list here. But if you've got questions, feel free to join in. Anyway, so this is what we're going to experience tonight. So we're currently almost to this phase right here. This is just the very, very beginning of a partial phase. I'm sure when I took this picture, we were sort of in the penumbral phase, which is what we're in now. But you can just, right here on this image, you can just start to see a little chunk of the moon being taken. I'm sorry, I don't think my mouse is showing on, it's not showing on that source. But it's basically the bottom, second moon image from the bottom there. And this is a composite. And I don't remember the timing on how often these pictures were taken. But you can see this is where we're headed. We should be reaching totality at about 11:26 local time. Again, I'm on the West Coast, so that's Pacific Daylight Time. 11:26 is when we should reach here. And then max totality is about 11:58. So right around midnight my time is when we will hit maximum totality. Hoping for some colors like that. But, you know, even if you are only able to stay up long enough to see the partial phase, there's still, it's still a cool sight. The moon is really, really high up in the sky tonight. This eclipse is going to not allow a lot of good like foreground subjects like mountains or anything like that, unless you're really close to maybe a tree or something. But I've got this shot here. This was a partial eclipse that I took from my balcony here, And I don't remember the year this picture was taken either, but it's quite old because it was taken, I believe, with my 12-inch Schmidt Cassegrain with a 0.7 reducer on it and a DSLR hooked up to the back of it. And this house that you see in the foreground is actually probably a quarter of a mile from my house. So that's why it kind of looks, it gives that forced perspective of the moon looking really larger than it actually is. It's sort of it's an optical illusion that you can see if you watch a full moon rise on the horizon. It's called the moon effect. And the moon will actually look really, really large when it's close to the horizon, and that's because your brain has something to compare it to size-wise. And if you go out 3 or 5 hours later when the moon is up high in the sky, suddenly the moon looks a lot smaller, and it's really the same size. I mean, it might have changed a tiny bit, but not something that's noticeable, with the naked eye. It just appears smaller because you don't have a nearby ground reference to compare it to. I'm going to save my favorite total solar eclipse photo for later. So let's go back to the live feed here. Just as soon as I come back to the live feed, you can start to see some clouds skirting through here. And you can see the telescope really kind of wobbling all over the place. I'm going to keep the exposure where it's at, so the moon actually might completely disappear here if this is a pretty heavy cloud bank coming through here. The most interesting thing that I've ever seen, Stefan, I'm hoping I'm pronouncing your name right, Stefan. Just tell me yes or no. If you get a few minutes in between explanations, let us know the most interesting thing that you've ever seen while looking into the sky. Well, let's see. The most interesting thing that I saw something that I got two stories, and I think we're going to have enough time here. I can probably squeeze both of them in if I just get to it. So I have a place that I go to sometimes. I do a lot of imaging from my backyard, first of all, but I use narrowband filters, which allows you to shoot under the light pollution of the city. I'm in the light dome of Las Vegas here, so it's kind of difficult. It's not impossible though. But there's several places that I go that are an hour or so drive from Las Vegas. I've got a place that I go to that's north of Las Vegas, and it's near a small community called Indian Springs. And the main thing that is in Indian Springs is Creech Air Force Base. Well, in Creech Air Force Base, is where they fly the Predator drones, among other aircraft there. And I was out there about 5 miles past Creech one night, and just minding my own business. I had my telescope set up. I was imaging, and I heard something, and I didn't hear it very. Joe is chiming in. Air Force Base, Creech Air Force Base, yeah, is the name of it. Anyway, I'm minding my own business, and I hear something, and as soon as I heard it, I looked up, and something just buzzed right over my head. And as it turns out, it was a Predator drone that was flying in to land at the airbase, which is about 5 miles away. And so I'm sitting there looking at it, and now I'm looking in the direction that the Predator drone is flying, and I hear something behind me, and before I could even turn around, there was another one, and I'm guessing it was probably maybe 1,000 feet above my head. So that really scared me, because I know that the guys that were flying those drones were seeing me for a long time before I ever heard and saw them. No lights, of course, and they were just in pitch black. So that's one thing. Another thing I had was, so I mentioned that was north of Vegas. So sort of east of where I live is Lake Mead, the big lake here. And there's an abandoned. It's not really an abandoned. It's a what is it? It's an airport, but it's only a runway, really. It's a runway and a tarmac, and it's out by Echo Bay. So you can find, if you look at Echo Bay on a map, if you can zoom in on Lake Mead, you'll see Echo Bay. And if you look sort of to the west of it, there's just a runway out there with a tarmac. Well, I was out there on that tarmac one night with my telescope once again, minding my own business, as I do usually when I'm out in the desert by myself. And I heard a helicopter coming my way. And the helicopter had like these searchlights on it. So I couldn't tell because all I could see was the searchlight, and I could hear the helicopter because it was really, really close to me. It started hovering above the runway and just kind of like going really slowly down the runway. And I'm on the tarmac, which is sort of at the midpoint of the runway. And it turned around and it shined the lights on me, and it completely ruined the long exposure that I was in the middle of doing. But anyway, I wasn't going to say anything. And then it came back in the direction that it came from and went to the other end of the runway, and it landed, and a couple of guys jumped out. And that was when I really got scared, because when the helicopter landed, the light was no longer in my face, so I could kind of see the helicopter. I could kind of see a little more detail on the helicopter. And I couldn't tell what type of helicopter it was, so I don't know if it was Metro search and rescue helicopter or what. But it landed, and the two guys jumped out, one on each side, and luckily they didn't start coming towards me, but they just got out and they were looking at something on the helicopter. I don't know if they were looking at the camera on the front or if they were just looking at the light, because they just went around to like the nose of the helicopter. And they got back in the helicopter and they flew away. And I know that's like two really boring stories if we're looking for like a little green man story, because I don't unfortunately have any of those. I do have a UFO story, and this is my third story. I forgot that I had this one. There's a state park in the northern part of the state that I like to go to called the Berlin Ichthyosaur State Park. There's an old gold mine town called Berlin, and I don't remember exactly when, if it was in the 1800s or early 1900s, they discovered dinosaur bones while they were digging for gold there. And the bones that they discovered were ichthyosaur dinosaurs, which is a water dinosaur, because the entire state of Nevada used to be a big ocean here, hundreds of or millions of years ago. And so I was there with a buddy of mine, and we had the telescope set up, and this was the second night that we were there. And the first night I had all kinds of equipment problems with my camera and everything, and to the point of frustration that I decided to take the camera off and put the diagonal on, which is a device that is used to insert an eyepiece into, so you can look through the telescope. Because believe it or not, people look through telescopes; they don't just take pictures through them. Anyway, so we were waiting for sunset, and off to the west, I could see this really, really bright object that was fairly close to the mountain range in the western sky. And my first thought was that it was Venus, because I remembered the night before, right after sunset, seeing Venus in the west. And if you've ever seen Venus in the western sky in the evening or in the eastern sky in the morning before sunrise, you know that it's incredibly bright, like super bright. It is, besides the moon and the sun, it's the brightest thing in the sky. I see this object as the sun's going down, and I'm thinking, well, that's just Venus, no big deal. And about 10 minutes go by, and I look back over in that same direction, and that object is still there, only the thing that's kind of strange this time is it's a little bit higher up in the sky. which, if you know anything about the way the sun and the moon and the stars and everything in the sky rotate, they rise in the east and they set in the west. Well, that object, if it was Venus, should have been going down and getting closer to the mountains instead of going up if it's in the western sky. So I knew right away it was something that was in our atmosphere. It wasn't a planet or a star or anything of that nature. So my buddy and I were sitting there and we're looking at it, and we're watching for probably like 5 minutes, and it's slowly getting higher and it's getting brighter, even brighter than it was when we first noticed it. And we cannot for the life of us figure out what it is, because it's now dark enough outside that we can see Venus, and Venus was off to the sort of to the south of where we were looking at that point. And I said, Glenn, let's just put the telescope on it and look and see what it is, because it looks like a UFO to me. And so we point the telescope to it, and the telescope has like a finder scope on it, which is like a low magnification scope, a little miniature scope that is mounted on the top of the telescope, because it's really hard to just randomly point a telescope under high magnification at something. So you need a spotting scope to kind of get you in the ballpark. So I'm looking through the spotting scope, and my buddy Glenn is looking through the eyepiece, but I'm looking through the spotting scope because the spotting scope has crosshairs on it, sort of like a rifle scope, and I'm moving the telescope into position to find this object. And when I'm at 8 power magnification, which is what the power is of the spotting scope, I can see that it's slowly moving, because when I would stop moving the telescope, it would start slowly drifting. So I had to put it on a slow movement control and sort of drift with it in the direction that it was drifting. And my buddy looks at it and he goes, "Oh, I know what that is." He goes, "I'll let you look first before I tell you what I think it is." And so we trade places, and I look through the eyepiece and I can tell immediately what it is. It was a weather balloon. It just so happened to be about the time that these fires were going on in the Northern California area. And so this state park is up near, close to Reno. It's south of Reno. So they were launching weather balloons over the forest fires, I think, to take images of it. I mean, I know they do that year round, but I think specifically because we could see the smoke along the western horizon too. So they may have been taking pictures of the forest fire with these balloons. But that's all it was. So it was a UFO until it was an IFO, an identified flying object. I hope that is entertaining enough. We're about, 10 minutes away from the beginning of the partial phase of this eclipse. And you can really see now, let me bump the telescope around here and get it back in the right, get it kind of more centered here. And then I'm going to bump the exposure up just a little bit. So we're at 4 milliseconds right now. So I'm going to go to about 6 milliseconds, and that'll increase the exposure. So now the top of the moon there is overexposed. But now that you can see that the top of the moon is overexposed, if this lower part here wasn't part of the umbral phase of the eclipse, this bottom part of the moon would be really, really bright as well. At least the white parts of it along the edges, here. The dark maras would still be darker, than like this part of the sky here. Let's go back. Let me turn this crosshair off and get back over here, and let's try 5 milliseconds. Oh, I did 6.5, so that's going to make it worse. Oh, I did 6.5 seconds. That's going to make it really worse. Let's get this back under control here. Sorry about that, guys. I wanted to change that to 5.5. Even that is still a little too bright on the top there. So let's go down to 5. Just ever so slightly overexposed here. Even if I wasn't live streaming, I do a lot of talking to myself like this. Yeah, the Reaper drone was definitely of those three. Well, I don't know. Actually, the helicopter story was scarier to me because the drone story happened so fast. It was, yes, there was a huge adrenaline rush for about 15 or 20 seconds there, but then they were gone. The helicopter story and the two guys jumping out of the helicopter, I had no idea whether they were friend or foe. So, yeah, that actually was the scariest to me. Let's see. Still a little overexposed on that top edge there. I might have to go down to just 4 milliseconds here. I was trying to keep this section here from blowing out. It's looking good though, and the wind, I believe, is calming down. So I showed this video earlier, but if you're new to the party here, so this is sort of what's happening right now. The moon is entering the outer shadow band that's being created by the Earth here, and so it's a barely noticeable part, and it's getting close. In about how long do we have here? 7 minutes is when the moon is going to touch this part here, which is the umbra, and that is when we will start noticing a very definite bite being taken out of the moon here. This animation's a little off. Well, I guess it's not. I guess we'll see a little bit of color before totality, but usually the color doesn't really happen until almost like minutes before totality begins, which will be about 11:26. And again, this is West Coast Pacific time, Pacific Daylight Time that we're in now. And I'm going to stream until we get to this part right here. That's when I'm going to probably stop streaming. I do have to work tomorrow, and I do need to get a few hours of sleep, so I won't be staying up for the entire part. But yeah, you can definitely notice that we're deep into the penumbral part of the shadow here. But there's a huge difference between this shadow and the shadow that's coming, and it's following directly behind it here. It'll be very obvious once the umbral part of the or the partial part of the eclipse actually starts. So I mentioned this crater earlier. This is the crater Plato, named after the Greek philosopher Plato. It's about 101 kilometers in diameter, or what is that in miles? 63 miles. I can zoom in on it a little bit. Let's get over here. So yeah. So when people ask, "Hey, can you see the flag?" Well, to give you an idea, that crater right there is 63 miles in diameter. The flag is, what, 3 feet in diameter? So that kind of gives you an idea of the scale that we're dealing with here. I'm going to look at, well, maybe I'm not going to adjust focus. I think focus with the weather that we've got outside right now, that's probably about as good as we're going to get. So let's go back again to the full disk. The other crater that you see down here in the sort of like the 4 o'clock position here, that is the crater Tycho. I think it's Tycho Brahe is, yeah, Tycho Brahe. That crater is about 85 kilometers or 53 miles in diameter. Interesting thing about this crater, and I'll zoom in on it, we've got a few minutes before partial starts officially. I'll need to talk about it now because it's going to be in deep shadow coming up soon here. So let me move this over here. So you can see, as I kind of center this crater up, you see these lines that are coming out from it. There's a dark line coming out this way and here and over here. And actually, if I zoom out just a little bit, you start to notice that these lines, these rays, kind of shoot out almost across the entire surface of the moon here. What that indicates is that this is actually a very young crater relative to some of the other ones, because what that is that's the ejecta, the material that splashed out from that crater when an asteroid plowed into the moon. And because the gravity is so low on the moon, the material just flew out in all directions, and you can see it. You can actually trace these lines, these rays going all the way out to other parts of the moon here, and they wrap around on that side of the moon there as well. The other relatively young crater here is Copernicus. That's where the cursor is right now. And trying to remember the details on Copernicus. I wrote some notes down. 93 kilometers in diameter, 58 miles. Let's see. I'm just looking at a few things here. Trying to find out where in the statistics. I don't live stream very often here. I was kind of looking to see how many people were here. I mean, I know there's a few people that have come and gone, probably. Partial eclipse is getting ready to start. Let's see. Kind of position the telescope where the partial phase here is at the bottom here. Alright, so there's my alarm. So that's telling me 1 minute until partial eclipse starts. A very distinct darkening though along that bottom edge of the lunar disk there. Hoping this weather holds out. I am hoping this weather holds out. Let's see what the weather forecast is looking like. So here's the NOAA. If you can see my cursor, this is about where we're at. So, and then it stops. The last frame before it loops again is from within the past 15 minutes. So you can kind of get an idea of the trend of which direction the clouds are moving. So it looks like we've got a pretty clear patch that's heading our way. So that's good. Back to the moon here. Let's do a little zoom in here and get a little bit closer view. Get rid of all my... get rid of as much of the graphics and stuff as possible. Make our image as full screen as possible. All right, so partial phase has started. It is 10:09:50. Yes, 10:09 is when it was supposed to start. So So we are officially in the partial phase of the eclipse now. So now we are, let's see, 10:09 to 11:26. 11:26 is when totality begins. So probably at, I'm guessing at about 11:10, 11:15 p.m. local time here is when we'll start noticing some reddening of the shadow. At the beginning here, it's just going to look like a dark black shadow creeping across the moon here. But as it gets closer and closer to totality, then what's going to happen is the rays of the sunlight are going to start seeping in around the edge of the Earth, and because the light cuts through the Earth's atmosphere, it sort of, not exactly sure, it refracts, and the red light gets bent further around, I guess, than the blue light. Sort of the same reason why you can look at a sunset when the sun is really close to the horizon and you can see it's sort of a reddish orange color sometimes. That's because the Earth's atmosphere is filtering out all of the other light. Well, that same filtered light where the sun is setting right now is creeping around the Earth and being refracted back onto the moon, and that's why it has sort of a reddish glow. So the deepness of that red kind of depends on the atmosphere conditions where the sun is setting around the Earth. If there's a lot of volcanic ash in the sky, then that's more likely to have a deeper color. If there's a lot more cloud cover, it'll be a deeper color. If the skies are clear at the time of totality, where the sunlight is creeping through, then we'll have a much brighter color, a brighter red color. But we'll still definitely see some redness. We're going to see that blood moon tonight. I wish I had not bumped my telescope earlier today when I was preparing for this, but things happen. Any more questions out there? As we start getting closer and closer to totality also, and the moon starts getting dimmer, I am going to have to bump up the exposure. You can see right now my exposure time is 4 milliseconds. So during totality, a millisecond that's 4/1000th of a second, which I think for some DSLR cameras that's probably about as fast an exposure as you can get. We'll go from 4 milliseconds up to probably 4 seconds during totality to just really bring out some of that redness. I think what I'm going to do now, guys, is because I started my countdown, my 15-minute countdown to Livestream almost exactly 1 hour ago. Here's what I'm going to do. I'm going to mute my microphone. I'm going to pump up the music, pump up the jams here a little bit, and I am going to make a run to the potty, and I will be right back. All right. I am back. Anything happened while I was gone? So if you're somewhere in the proper viewing range, you should definitely step outside and have a peek at the moon. It's really kind of a cool look to see a full moon with a big bite taken out of it. Oh, I have a visitor. My dog came to see me. After my little break, I grabbed a popsicle, so he knows he gets to lick the popsicle stick when I'm done. You gotta wait, boy. You gotta wait. It's a very cool to be live streaming once again. I can't believe it's been a year. So this is a little graphic that kind of shows, obviously not at all to scale, but it kind of explains the difference in in what we're seeing with the shadows. So the light rays of the sun still get around it whenever it's in the penumbral phase here. And once the moon reaches this point here, well, actually the moon would be going, well, this whole graphic is really not very realistic, but once the moon gets to this point here in the deep part of the shadow, that's what we're seeing now, where there's a big chunk missing from the moon here. Oh, Australia. Australia's in the house. I'm sorry, Beverly. You lost the prize for longest distance viewer tonight. In fact, Teresa's going to probably take that prize home, because I don't think we're going to get any viewers further away from Las Vegas than Australia. Welcome to the feed, Teresa. We are, let's see, the partial portion of the eclipse began at 9:10, so that was about 11 minutes ago local time. And totality begins at local time 11:26, so that's a little more than an hour from now till totality. So Teresa, have you just joined us, or have you been watching for a while? You missed all of my great non-UFO stories. I don't know. We're going to be here long enough. I might have to tell them again. I'll probably have a new audience, a completely new audience in 3 hours anyway. You might even get lucky and get a chance to see my puppy dogs. One of them is sitting here. I'm sitting here eating a popsicle, and one of them is licking his lips, just waiting for me to finish so he can have a lick on the popsicle stick. Okay. So you just joined us. Well, welcome again. There's about probably a Well, I timed it earlier today when my countdown was going because I had a clock counting down the minutes and seconds. There's about a 28-second delay between the time that I say something and you hear it. I guess because of all the servers and everything, all of the digital bits have to make it through. And I don't know if there's an even longer delay getting all the way down to Australia. I would imagine there might be another second or so in there. So if you ask a question via typing it there in the chat, it's going to be at least 30 seconds before I see it, and then another 30 seconds before you hear my answer start. I have a question for my viewing audience. Is the background music too loud or not loud enough? Because I don't talk a whole lot, so you guys chime in. Or perfect, that would be an option too. So not loud enough, perfect, or too loud. Oh, my good friend Dr. Clay is joining the party. I was hoping you would get here, Doc. I don't know if you're viewing the chat, but we've got a couple of local people. We've got someone from South Dakota. You're in Arkansas, but the winner of the long distance viewing is Teresa, who's viewing from Australia. We got really lucky with the clouds. I had my live stream set to start at 9:30 local time, and I couldn't see the moon until about 10 minutes after 9. It was in such deep, heavy cloud cover. Okay, Beverly says the background music is perfect. Well, thank you for the feedback. I'll keep it where it's at then. This is really, I don't know if any of my viewers are live streamers or do any kind of podcasting or anything like that, but I'll give a plug to Simon Wilkinson here. It's royalty-free music, really, really cheap. I mean, it's just incredible. And this is an entire album, so there's like over an hour of music, and I just have it playing on loop in the background. And it's for an astronomical related live stream, I guess. I think it's a really good fit. It's the Blue Mask, thebluemask.com. I think it was only like $40 for an hour of music that I don't have to worry about licensing fees or anything of that nature. So a really good deal, especially since I've gotten so much use out of it. Bless you. My dog just sneezed. You have to come here. Come here, little man. Come here and say hello. Let me grab my camera and kind of get it aimed in the right direction here first before I switch over. There he is. What's up, little man? That's my boy Sagan. Uh-oh, focus. Come here. This is the popsicle stick licker. It's not focusing, boy. It's not focusing. All right. I have two labs. I have this crazy little critter here, and I have a black lab as well. And Sagan, of course, is named after my astronomical hero, Carl Sagan. And my other dog is Titan, and he's named after Saturn's largest moon, Titan. And he's up in bed with his mother right now, so he's probably not going to make an appearance tonight. So you're the one that gets all the airtime. All right. This guy usually is sleeping in my spot on the bed until I go to bed. But he heard me in the refrigerator earlier and decided that he needed to come and inspect what was going on. Anything for the possibility of a treat. All right, I'm not getting a lot of questions from my viewing audience, so I'll have to ask a few questions, and feel free to chime in or not. How did you find my feed? That's what I want to know. There's a couple of you I know how you found my feed because I sent you text messages. But for some of the other people, I know Stardock is a good friend of mine that lives in Arkansas, and I sent him an email letting him know that I was going to be doing this with a link to the feed, so I know how he found out. No, Beverly, he is definitely not little, but he's little compared to my other dog. Oh, speak of the devil, he decided to make appearance. He heard me talking about him. All right, you got to see the other guy too. All right, here's Titan. Now, Titan, unlike my other dog, does not like seeing himself on the computer screen, and so he's going to jump up and get a little crazy here because he sees himself on the monitor. It's okay. Oh, I know. You got to get down. Okay. That's Titan. They both actually weigh about the same. They're both right at 80 pounds. Back up. Now he's seeing himself on the 30-second delay. Don't jump on the computer monitor. Okay, go lay down. Go get in your chair. Okay, thank you. He very, very rarely comes downstairs once he's gone to bed for the night. He will stay, but there is a little bit more of activity going on. I'm not normally talking to myself either, so he probably heard me talking and thought somebody was in the house that he needed to come check out. Titan, the black one, is definitely the guard dog of the house. My other dog, Sagan, if we had jewels in the house, he would show any burglar exactly where they are if it meant getting a treat. But this guy does not like strangers. Titan does not like strangers. I don't know that he would actually bite anyone, but he does have a vicious bark. Well, I can tell by the wobbling of my moon image here that it is getting a little breezy outside. I'm hoping that doesn't pick up again. Up my exposure just a tiny little bit here. I have to keep putting my chat window up on the side of my screen here so I can remember to keep an eye on it. Well, the eclipse is moving along at the speed of grass growing here. Actually, maybe a little bit faster. It's coming up on, it's 10:30, about 10:32 local time, I believe, 10:31. And we've got, let's see, max or totality begins at 11:26. So we've got about 55 minutes or so till totality begins. And if you remember earlier, I was pointing out my exposure time right now where the cursor is. It's at 4.10 milliseconds. I just bumped it up from 4 milliseconds. So it's, but you're starting to see that penumbral part of the eclipse is fully covering, I think, the surface of the moon. So I think my exposure is going to have to go up a little bit here. We're going to start with a small bump from 4.10 to 4.4 and see what that does. That increased it a little bit. All right. Yeah, Doc, I know what you're talking about with the weather, because I was, let me call that up. This is what I've been looking at all day too, just watching the trend of which direction things were going. So it's where my cursor is here is where we're located, right on the southeastern edge of this big bright blob of Las Vegas lights here. And so we're definitely not crystal clear out there. There's some high thin cirrus that we're shooting through for sure. But as I look out through my live webcam here that's monitoring the observatory, I've got a little red light on it just to kind of like, because I love the contrast of the red light on the walls and the bluish color of the sky here. Eventually we'll see the moon creep in here as the telescope follows it. Here's another little graphic that kind of shows what's happening here. So, you know, you've got the Earth rotating around the sun, and then you've got the moon orbiting the Earth, and neither one of them orbit in perfect circular paths. So for the moon, it's perigee is when it's closest, and apogee when it's furthest. And I'm not sure where we're at. I did not look up the details for tonight's moon to know whether it's furthest from us or closest from us in our orbit. I bet you I do know somebody that's listening that could answer that question. Oh, thank you, Beverly. And yes, Doc, I am using the 152, my 152 for the feed. There it is once again. I've had some trouble with my astrophysics mount, so the astrophysics mount is in the more than capable hands of Patrick, who you met during the eclipse last April. He's trying to work out some issues that I've had with it. So I've got my Ioptron, my Sim 70, mounted in the observatory now. I wanted to get back to doing some imaging instead of troubleshooting. So the Sim 70 from my Ioptron has not failed me yet. And you can see my neighbors just turned their searchlight on. They've got a spotlight mounted on the side of their house that lights up my yard, but not theirs. And I've asked them to please. And it's got some sort of either timing on it, or if it catches something breezing by, maybe it's a motion sensor, but you can see they just turned that light on. Anyway, so yes, Doc, that's the scope. Same scope I had at your house for the solar eclipse last April. Oh, wrong way. And I don't know, Doc, if you were here when I said it earlier, but I was switching from my mono camera to my color camera so that we could see some of the reds tonight during Totality, and I bumped them out, so that's why my image is drifting a little bit here. I've got to nudge it probably every couple of minutes here. I did not have a chance to do a polar alignment because my stream started before the clouds cleared in the northern part of the sky here for me to do a quick polar alignment. All right, let's bump up this exposure a little more. The wind is definitely picking up a little bit right now. Well, on my webcam that's in the observatory, it's looking really clear out there. It's amazing that I'm even able to do deep sky imaging here with my neighbor's light on like that, but I do get some gradients in my long exposures every once in a while because of light reflecting off the side of my house into the telescope, but with the moon tonight, that's really not much of an issue. Wow, the wind is really picking up out there. I can hear it. Well, I will show you now. I will go, let's see, let me switch over. I want to show you my favorite lunar eclipse photo. Let me switch over to it here. Earlier this evening, I showed this picture here, and it's a composite taken with each individual frame was shot with a DSLR and then composited together to just kind of show the sequence of what we're going to experience tonight from bottom to top left. But that's not my favorite. That's not my favorite eclipse photo. This is actually my favorite. I was working a job a few years back, and I had to be in San Francisco, and that thin layer of clouds there just hovered. It never moved the entire time, and that was as high as the moon got in the clouds there. But this is the Bay Bridge in San Francisco. And I just love it because I think the composition with the arches of those lights on the bridge there, and all of the wharf lights there on the horizon, it's kind of a cool shot. So that's my favorite. My favorite thing to do with the moon, though, besides just taking pictures of the moon, is I like to do transits of the moon by the International Space Station. So I'll go ahead and play this little video too. So this is the ISS transiting the moon. Read the details there real quick. So this is from December of 2017, and it's going to loop because, as you can see, it happens really, really fast. But that is the International Space Station flying in front of, and I slowed it down here, I believe, a few times too, so you can see the space station a little better. But yeah, so that's kind of cool. I like doing solar transits too. Anyway, that's that. Let's go back to our live feed of the partial phase of the moon now. I was very, very worried about our stream earlier this evening. It actually rained here today, which for the locals, you guys know how rare that is, but it's pretty rare for it to rain here, especially this time of year. It seems like we get most of our rain August, September during the monsoon season. The clouds will come up from the Pacific coast here and from the Gulf of California here up through Arizona and circle around, and we'll get monsoons. We'll get torrential rains. And when I say torrential rains, I know someone from the south is going to laugh at me, but we get enough rain that the streets will flood here, and that's because we don't really have drainage here other than just gravity pushing everything downhill. We don't have enough rainfall to have gutters and underground drainage for the most part. All of the neighborhoods. That was one of the strange things, because I grew up in New Orleans, and moving here from New Orleans, where it rains 4 or 5 inches in a week sometimes, and we get 4 or 5 inches in a year here. It was quite the difference. Anyway, let's get back to our feed here. Still about 40 minutes away from totality. So yeah, if you were curious about whether it was windier outside or not, you can see I've got a little small piece of a Mylar blanket that I have taped to the edge of the wall there, and I use that as a windsock. If that's blowing, then I know it's windy outside, and I know not to expect too much. But you can also see how, just the top edge of the winds are coming in from which direction are they coming in? They're coming in from the northwest, I guess. Yeah, they were coming from the southwest earlier today. They're coming in from the northwest, and so that would be sort of the direction of this corner over here, headed this way. coming from the northwest. But yeah, so the wind is going to hit that and kind of bounce the image around just a little bit. I'm surprised, honestly, it's as steady as it is right now. Oh, don't want to see my ugly face. So there's our image. But yeah, it definitely has a little bit of a wobble to it. Doing here. Has anyone actually had a chance to see it visually? Stepping outside and actually looking at it with their own eyes. I mean, I know who's Australia? Teresa? Is Teresa Australia or Beverly? I'm sorry, I forgot. Teresa's from Australia. So is it? I don't think it's visible in Australia at all. Let's see. So I was just looking at, let's see, can I switch over to this source? 3 a.m. Sydney time, I believe, but we have, oh, you got cyclone clouds blowing in, okay. Well, I'm glad you could join us. Yeah, I was just looking at this map here, so it does look like, at least if you're on the eastern side of Australia, you'd have a better chance of seeing a partial eclipse anyway. This section here, oh, I keep forgetting that I gotta move my mouse over to this screen for you to be able to see my mouse at home. So you have to be living inside this loop here to see any of the totality. So the outer edge here is Australia, so you will see some of the total. Does it say some of the total phase? It does. Missing parts of total. Some of the partial phase, I guess, is what that I'm having a hard time discerning the. But again, yeah, with cyclone clouds and everything, that's not going to be much chance of seeing anything there. I was running back and forth today in the rain, back and forth to my observatory while the roof was closed, of course, switching cameras out and testing things, and was wondering if I was just wasting my time, but I'm glad that I put the effort in to be able to do this for you guys tonight. Definitely time to start bumping up the exposure time. Let's go to 7 seconds. 7 milliseconds, I'm sorry. Well, we could probably do even a little bit more than that. Let's try 9. There we go. That's probably about as bright as we can get it. No, let's try 10 and see what happens. 10 milliseconds. That's good. So you can see at the beginning, when we were just in the penumbral part of the eclipse, that we were at, I believe, what were we at? 4.4. Beverly gets to see it. Awesome. Beverly's in South Dakota, so apparently the sky's clearing up enough up there, so she can have a peek at it. That's great. I'm glad you stuck with it and had a chance. Yeah, Doc, you know how much I love doing these things. I wish I had time to do more live streams. The new job kind of puts a little bit of a damper on doing live streams unless I do it after work, which would be starting midnight local time. But I can always do it on my days off. I've got quite a lot of free time in April coming up, so I will try to get out and do something else, do some more live streams in April. I might do some sharp cap live stacking tutorials or something. I used to like doing that. So we're coming up on 30 minutes till totality. 30 minutes, guys and gals. I was doing a little. It is a mystical feeling, and I am going to make it a point in a few minutes of going out to actually look at it with my eyes. I don't want to just do the entire eclipse here, standing behind the computer or sitting behind the computer. I was doing some research today, trying to refresh my memory on a lot of things, and there's an interesting story I found about Christopher Columbus and lunar eclipses. So they were smart enough to know, or to have almanacs to know when they were going to happen, so they knew. And when he was stranded in Jamaica, he was not being treated well by the local indigenous folks. And so he went to them and he told them that they should treat them better, or he will make the moon turn red or turn to blood that night. And he knew it was an eclipse coming that night, and so they didn't believe him. But of course that night the moon turned blood red, and they went back to him the next day thinking that he was, or his people were gods, and they took very good care of him at that point. So I don't know if that's true or not. I'm sure I know somebody that's listening that could chime in and has more details on that story. Tell us about it, Doc. Have you heard that story before? Is it true? And did I get the gist of it correct? I know I didn't get a lot of the details probably right. I'm gonna hit the mute button, pump up the volume here on the music a little bit, and I am gonna step outside real quick so I can see it before it gets dark here, or before it gets to totality. I will be back in a moment. Yes, it is a very strange look to see a full moon looking more like a crescent, upside down crescent moon. I'm back. Let's see. Yeah, it's hard to not get... you can't go to bed now, Beverly. You've got to stay up at least another half hour or so and see totality if the skies are clearing in your area. Let's see, Doc says the story is out there and you relayed it well, but whether it happened is still up for conjecture. Okay, well, that's fair enough. I can tell you I am going to bump up my exposure here again. So now we're at 15 milliseconds. Started out at 4 milliseconds during the full moon, or when the penumbral phase of the eclipse was first starting, and now we're up to 15 milliseconds. Let's see. Okay, I'm going to switch over to my Stellarium program here. If I zoom out here, you can kind of get an idea of where we're at. So this is in my observatory at the point of the telescope looking due south here. This line here is called the meridian. It's a point, imaginary line that goes from south to north. So if we turned around in the opposite direction, we would see north. And you can see the compass rose there. But we are looking at the moon right now. And if you've never, and I've got a photorealistic view of what I can see from my observatory. So you can see that my house blocks quite a bit of the view here. And if we went back in time, I'm traveling back in time now. You can see when it clears the roof of my observatory right about there, which was at about time-wise 8:26. Yeah, I think it was about 8:30 when I could see it through the telescope, and it was just clouds. Going back to the present time, and this is that's the field of view of my camera, and we can see the phase that we're in now. So something that's interesting is during totality, let me speed up and show you what's about to happen here. Slowly going to creep up there, and at about 11:30 and in about another 22 minutes or so, we'll be in totality. And you can see there's 2 stars here. I don't know if they've just got SAO designations, probably, yeah. But those stars will probably be bright enough and the moon will be dark enough that we should be able to make out those 2 stars. And let's advance the clock a little further and see if those stars are going to get occulted by the moon. They will. At least one of them will. Both of them will during totality. So that'll be something interesting to look for. Oh, and there's a satellite that's going to fly through. Oh, let's see if we can find out what satellite that is. Right there. That's a Starlink. Well, that's a big surprise. So at some point in time there's a satellite that's going to pass through during totality, but we won't see that because it's already in the shadow. I've got to turn my Roomba off. My Roomba goes automatically at 11 o'clock every night. And it's getting ready to run in here and start making noise. Wrong password. Okay, well, I guess I can't turn it off now. Alright, let's go back to current time. And let's go back to actual real time. Let's minimize that. Here's our live feed. So I've bumped my exposure up to 30 milliseconds now. To see if we can start to see any of the color coming in. I think I'm going to have to probably really overexpose it to and blow out that visible part to start to see any of the color. Let's see what we can get out of it. Bringing it all the way up to 126 milliseconds. Now you can start to see, if I really overexpose it, you can start to see a little bit more of the disk here. But we're going to hold off on that until we get closer to totality here. Let's go back to 30. .25 gives us still a good exposure along that upper left-hand corner there that's still lit properly. And the moon is finally starting to clear this camera's point of view. We can see the moon shining brightly in my little webcam that monitors the sky there. Wrong camera again. Don't want to see my ugly face. I'm just answering a couple of emails here while we wait for these final few minutes. Oh, there's another Joe I was supposed to give a shout out to. I don't know if he's tuned in or not. Joe from work. Besides UFO Joe from work. Another Joe. I said I'd give you a shout out. And so here it is. Hopefully you're watching. We're still about 15 minutes away from totality beginning. Speaking of shout outs, give another little shout out to my background music, Simon Wilkinson's thebluemask.com. This is royalty free music if you do live streams and podcast or any of that type of stuff and you need some good ambient sci-fi-ish kind of background music. This is the guy to get it from. I'm curious what the SharpCap software. SharpCap is the program that I'm using here to do this live stream to capture from the camera, and it has an auto exposure. I'm just going to make a note. 25 milliseconds is what I'm saying the proper exposure should be. Let me put it on auto and see what it does. Oh, it's bumping it way up. See, it's going all the way up to over a second. Almost 2 seconds now. 2.2 seconds. There's no end in sight, but we get to see a little bit more of the you get to see the color now. It's obviously, starting to get that reddish tint. So if you're at home watching and you have clear skies, get outside and take a peek at the moon right now. Sorry, I keep nudging it, and it's doing rather long. Ooh, it's actually doing 4-second exposures right now. 5-second exposures. I'm going to take another quick walk outside and look and see if I can start to notice with my eye any of this redness, or is it going to be just more like that. I shall return in a moment, folks. Enjoy the music. Okay, I'm back. Yeah, I think it is going to be a deep red eclipse, Doc. Yep. Just catching up on the chat window there, making sure I didn't miss anything. All right. I don't think I'm going to go back to the auto exposure, but I am going to start bumping this thing up manually. Just to start seeing a little bit more of that red that's coming out here. When you overexpose the surface that's still under light, you can really see a very distinct line of where the shadow is and how much more we still have to go just in the next few minutes. Seeing in these 1.1 second exposures, I'm seeing ever so slightly just a little bit of redness along the edge there. I don't know if that's going to come through on the live stream feed or not with all of the YouTube compression that happens. Of course, with these longer exposures, I have to be a little more careful when I'm nudging it because it's going to blur during these long exposures. Well, I'm glad you're able to actually see a little bit of the moon anyway through the clouds there in Arkansas. Maybe it'll be just like the April solar eclipse, and you know the skies will clear up here during just before totality. Let's see. Teresa has a question. The shadow line is not smooth. Is that the landscape of the moon or the shadow of Earth's landscape? I think it's just because, if you remember, the moon is not like just one solid color. There's some dark areas and there's some light areas. And I think it's just because I'm so heavily overexposing this part of the moon that it's kind of blending in with the lighter colored surfaces. The mares or the seas are the much darker regions, and I don't think at this kind of resolution, the shadow is too soft. It has too soft an edge, I believe, to be able to see any kind of detail. It's not like a total solar eclipse where if you have some extreme magnification, you can actually see the mountain ridges along the edge of the moon. I think it's different with the Earth, because remember, most of this light is cutting through the atmosphere too, not so much the Earth itself. Another viewer from Arkansas. Welcome. I'm going to adjust my exposure down briefly here. We are very, very close to totality here. And again, what you're seeing right now are changes that I'm making with the camera, adjusting the exposure on the camera. So this is not happening, this change that you're seeing is not happening live. This is an illusion made by the camera here. But you are starting to see some of the red now, very easily showing up here. I think Doc just said that that the red was showing up in the feed, so that's good to hear. Let's see, totality set to begin at 11:26, and current time is 11:17. So we've got 9 minutes till totality. It's crazy whenever you really crank up the exposure and overexpose that top left side here. Watch this next exposure coming in. You can still clearly see the larger features. You can see Plato still. You can make out Tycho here, the crater that we were talking about earlier, and the Maris, of course. So this is Mare Tranquillitas here, the Sea of Tranquility, where Apollo 11 landed. If I remember correctly, it was somewhere right around in this region here, where they touched down. Let's go crazy here. Let's go do a 8-second exposure and see what happens here. So now it's taking an 8-second exposure. You can see in the bottom left-hand corner. Oh no, I've got that part cropped out here, the bottom right-hand corner. There's an 8-second exposure. So it's taking continuous 8-second exposures right now. Really starting to see that red come through. I don't want to, if you don't really understand too much about the way these astronomical cameras working, so it's taking continuous pictures and feeding it live like a video camera, except with much longer individual exposures. So that's why, let me go to, here we go. So now in the bottom right hand corner here, you can see the exposure time as it's taking a picture, and then it'll refresh on the screen. So when I make these drastic changes in exposure times, now I'm down to 2.2 seconds here, just because I want to get a little better idea of how far the shadow is from covering the moon. If I go all the way down to 1 second, we'll get a much better idea of, or 1.4 seconds. Let's go to 3/4 of a second. You're welcome, Teresa. I'm glad you're enjoying the feed. I wish we could actually, like, rather than through chat text here, I wish we could actually talk to each other. That would be so much more fun, but it would also get probably a little crazy too, with a bunch of people trying to talk at the same time. There'd have to be some sort of moderation of that. And of course, you could do a Zoom call, but I had enough Zoom calls during COVID. I'd be perfectly happy not ever seeing a Zoom call again. Let me move this scope a little bit. All right. Back to 5-second exposures here. There we go. So now you can, now that I have the view on showing the full frame here, you can see the exposure and the frame rate down here. So it's You can see it's taking 0.2 frames per second, obviously, because it's taking 5 seconds just to do one frame. So, but I do like to go to this view here. It gives a little bit closer up view. Yeah, I'm guessing Arkansas might already be in totality. We're still a couple of minutes away from it. And even after officially totality, the edge on a long exposure is still going to be a little bit bright, and we'll see that brightness move because I don't think we're cutting right through the center of the shadow. I think we're kind of skirting the edge a little bit. Yeah, Doc, I can't tell. I do want to step outside and actually see it with my eyes during totality, and I'm definitely going to do that. But with me making all of these different exposures changes and everything, it's hard for me to really tell what looks like reality without stepping outside. I don't have a window that's where I can see the moon now. I could see it out of a window earlier. But the other, actually, if I stand up, I probably can. No, I do have a couple of windows facing south, but I can't find the angle to get it. So we're 2 minutes to totality here in Vegas. 2 minutes. I am going to, what we're looking at right now is a cropped view of the sensor. At some point in time during totality, I'm going to show the full sensor so I can see if we can find those two stars. I'm going to do some long exposures too, like maybe 10 seconds or so, and see if we can bring out those two stars that we saw earlier in the Stellarium planetarium program. They'll be coming in from the bottom down here, I believe. Okay. Well, folks, we should be in totality at this point. And totality is going to last until 12:30, so a little more than an hour, from 11:26 to 12:31, so just a hair over. So we're still about 30 minutes away from max totality, where we should get rid of this bright edge here, and we should be deep into the shadow. I'm going to fool around with some exposures here. Let's see what we can do here. Let's do double that. Let's do 10 seconds just for the heck of it and see what it looks like. So it's starting a 10-second exposure now. And you'll definitely know when the 10 seconds is up, because it will drastically change this view. There we go. That's a beautiful shot there. And I think we're starting to see the stars also that I was talking about down at the bottom of the frame here. There's one there where my cursor's at. Let's see, like right there, and then there's one right over here. Let's see. Very interesting. Well, there's your blood moon, guys and gals. All right, I have to go down to a much shorter exposure here for a moment. I want to bump the telescope again. Wow, short exposure, I can barely even see anything. I want to, my scope is drifting ever so slightly, so I want to get it up sort of in a higher section. I kind of know it's very slowly over time it's drifting in this direction. Not much, but it's enough that it's, if I didn't do any type of little minor adjustments here, it would eventually drift out of the frame. Now that it's up in more or less the upper left-hand corner, not 5 milliseconds, 5 seconds. All right, 5-second exposure coming in here, guys. There we go. I'm going to take a walk outside since Totality has started. I want to see what it looks like to the naked eye, and then I'll come back in and I'll see if I can, and by adjusting the exposure, if I can replicate what I'm seeing outside with the naked eye. I shall return. All right, I'm back. And you know what? That is very close to what I'm seeing with the naked eye. Let me make a very minor exposure adjustment here. And let's say, that's 5 seconds. Let's say 4.5 seconds. And see if that looks, not this, because it's resetting and doing a new exposure. Yeah, that's pretty close to what I saw stepping outside just a moment ago. So it is a dark one. It is going to be dark. But I think that's a pretty accurate exposure. If anybody else has got a chance to look at it and come back in. So Beverly's seeing it very clear in South Dakota. So tell me, Beverly, do you think that what I'm at the exposure that I'm at right now looks fairly close to what you're seeing with your eyes? I think it is. I think that's about as close as I could get to recreating it. got to move that over to another screen for a moment. Let's see. Nobody's talking right now, so I'm guessing everybody that can has a view is outside looking at it with their eyes, which is good. That's the best way to view a total lunar eclipse anyway, is to actually witness it with your eyes. Alright, so let's see. So if you remember earlier, I was showing you my stellarium program. Let me go back to this view here. So this is the view that shows my camera. Now remember the relationship of this very unique feature, this round feature, meridian, I believe, or chrysium. I'm not exactly sure how to pronounce it. So it's on the opposite side of the moon. From that, you see two stars. They're getting very, very close to the moon. So now let's go back to our image here. So here is that feature of the moon. Opposite side is down here, and I'm pretty sure I'm seeing that star, at least one of them. I think both of them. Let's do a 10-second exposure here. Let me get my exposures changed here. 10 seconds. Why is it not letting me change that to 10 seconds? Here we go. Okay, so it's resetting. It's taking a 10-second exposure, and let's look along the bottom edge here, and we should see these two stars. One of them very close to the moon, and there it is. You can see it under my or right by my mouse, and then there's the other one. And if we switch back to this browser view, there's the one that's really close to touching the moon, and there's the other one. So we're actually going to be able to witness, going back to the live view here. Let me zoom in on that. Oh, much easier. I know Doc remembers when we did the Mars lunar occultation. So you can actually see how fast in these 10-second exposures, you can see it's taking an exposure every 10 seconds. Here comes another one there. You can see how fast the moon is moving in relation to the background sky. So that star is going to disappear here very shortly. Okay, I'm just catching up on the chat. So I did change the exposure to 10 seconds, so you should be seeing it, and that's probably going to be the last 10-second, the last exposure that shows that one star. Yep, that star is gone now. So if we pan over to the other side here, there was another one that was a little bit further away. Oh, we can actually see two stars there. Although that, I think, is probably a hot pixel on the camera, like this little green hot pixel there. But that's definitely a star there that should be visible now in the feed. Anyway, we got to see one star disappear. So Doc was asking me, you might want to explain the difference in the light gradient density from the upper left edge to the deep darkness at the lower right. Well, I do have that graphic earlier that showed, you know, if the moon was passing directly through the center of this circle that's labeled umbra here, then we would probably lose that. But I think because it's not quite skirting the center, or that because it is skirting sort of the edge, I think we're never going to lose that brightness on one edge, because in the center of this circle labeled umbra is going to be the pitch darkest part of the eclipse. And if the moon was passing through that section, then we would get rid of that light edge. But I think because it's kind of close, as you can see, close to the edge there, that we're going to probably always have one edge of the moon, that top edge, that's a little bit brighter than the bottom edge. I'm sorry if you guys are hearing my Roomba. It's running on the ground right under my feet practically right now. I tried to log into the app to park it and tell it to go home for the night, but it cleans every night at 11 o'clock. So it's it's cleaning the floor right now, right behind me, making noise. In between words, I'll try to remember to mute my mic so you guys don't have to listen to it. We're getting ready to see that other star. It's literally touching the edge of the moon right now. And I think the next exposure is going to show that it's gone. Yep, there it goes. So I don't know if these hot pixels are showing up in the live stream, but there's a red pixel there, there's a green one there, and there's one down here. I can't tell what color it is against the dark black background, but that's sort of normal for these type of cameras that do really long exposures to have a little bit of what they call hot pixels or cold pixels. A cold pixel would be a black dot that shows up against a white background. I'm going to quickly adjust my exposure here so that I can move the telescope once again. let's go back up to 10 seconds. There we go. There's what the live view looks like from my little webcam that I've got mounted on the ground in my observatory looking up. You can see the moon up there. And you know what? I just realized there's something else kind of cool. Let me go back to this view here. I have an AllSkyCamera that's mounted on my roof. If you're not familiar with what an AllSkyCamera is, it is... it's a camera that's mounted in a little box on the roof of my home. It's got a crystal dome on it, and the camera has a fisheye lens on it that's pointing straight up in the sky. And so what it does is it takes a picture of the sky. Let me see, what do I got to do to switch over to this view? Just this. There it is right there. So that's the camera that's mounted on my roof. You can see it's not quite clearing my roof on the left-hand side of the frame here. You can see the roof of my house because it's about parallel with the top edge, but then the roof angles up a little bit. Those are my solar panels that are on the roof there. And there's the moon. So it's taking a picture. It does an auto exposure. So if it was taking pictures in the daytime, it would be obviously very, very short exposures. And it tries to, just like what we were looking at in the feed here earlier, it tries to make a correct exposure for the view with a maximum exposure of 15 seconds. So what it's doing now during totality is it's taking 15-second exposures every 15 seconds and then updating the feed. So you'll occasionally see a little streak or something that runs through here, and that's an airplane flying through. I'm surprised, being so close to Las Vegas airport, and it's before midnight, so they're still flying in and out. I'm surprised that we don't see any air traffic. Just want to confirm that this is a live feed. Let me look real quick here at the software. Yep, it is running. So if you look at my channel, well, let's see, what have we got coming up here on the horizon there, on the right hand side? That's due west. I don't know if that's an airplane or something that's coming. Yeah, you can see that that's moving. So that's an airplane probably with its landing lights coming into McCarran. Or, I'm sorry, what do they call it now? I don't remember the name of the senator. Harry Reid International Airport. Let's see some weird cloud patterns on the southwestern sky there. North is up in this photograph. You can just make out the Big Dipper right here. So these two stars right here are what they're called the pointer stars. So they point directly towards Polaris, which I believe is just outside the field of view at the top of the frame there. Anyway, let's back to the eclipse here. I'm hoping my vacuum cleaner finishes rather soon and goes back to its home base. Just last week I was able to log into the app and control it, and for some reason it's telling me I don't have the password now. Okay, Beverly, thank you for joining us tonight. I'm glad you enjoyed the feed. You can come back tomorrow and look at the highlights and look at the live stream, or it's recorded, so it'll be not live obviously, but it'll be available for playback after I end the feed tomorrow. And the vacuum cleaner just finished. It's headed back home to its home base. Switching back, you can see now that airplane is getting closer. So that's how far that airplane has traveled in 15 seconds. And you can see another one coming in right behind it. So I will be when the live stream ends tonight, I will probably be going directly to bed because I have to work tomorrow as well. Not probably as early as Beverly, but I have to work till midnight tomorrow. But at some point in time during the day tomorrow, I will edit the live feed to have in the description below the video, I will have a table of contents, so you can jump directly to the parts of the eclipse that you want to see. So you're leaving now, you're going to miss maximum totality, or are you going to miss maximum totality? Well, it's coming up in a few minutes, so if you've already gone, you can come back tomorrow and look at it. And you'll be able to jump easily to maximum eclipse. I would like to, since we're getting close to maximum, I would like to bump up the music and mute the microphone and run outside and take a look at the moon myself. So I shall return momentarily. All right, I'm back. And guess what? Guess what else is back? The vacuum cleaner is back. Apparently it was not done with its job. It simply had to go back to the base station to empty the bag. So it's running under my toes again. But I did go outside and I did look at the moon live. And I'm very curious to try and replicate what I see with the naked eye. So let's see. 10 seconds is definitely too long. That is way brighter than the moon that I'm seeing outside right now. So let's try 8 seconds. So it's going to take an 8-second exposure now. We'll see if that looks a little more realistic. Nope, that's still a lot brighter than what I'm seeing with the naked eye outside. Let's try 6 seconds. So it's resetting and taking a new 6-second exposure. That's still brighter than what I'm seeing with my eyes. Let's try 5. Okay, it's taking a 5-second exposure now. Yeah, I think that's more like what I'm seeing with my eye. If anybody's out there and can see the eclipse actually right now, tell me if that's what you're seeing, or if you're seeing what exposure you would like for me to try. This is a 5-second exposure looping right now. So this next one's going to be bad because I just moved the telescope again. All right. Yeah, I think that's kind of what the moon looks like to me. Log into a couple of other YouTube channels. There's some other people that I follow on YouTube that are streaming the eclipse live as well right now. Their views look very similar to mine. Not that I want anybody to leave my channel, but there's a guy who has a channel called Nebula Photos. Nebula Photos. 8 seconds equal the Death Star. 8 seconds equal the death. Let's go back to 8 seconds. Let me see what 8 seconds looks like. 8 seconds. That's pretty funny. All right, so it's taking an 8-second exposure now. Let's see. Yeah, that does kind of have a little bloody Death Star look to it. Chuck's Astrophotography is streaming live as well. I wonder if he's streaming from his observatory in Texas or from his driveway in Detroit. He's got a couple of he's switching back and forth between both of his driveway and his observatory in Texas. I think he's overexposed. The moon's not that bright. But we're not going to tell him that. It does look interesting. His exposure does look a lot brighter than mine. I wonder what kind of exposure time he's doing. I'm not going to pay that much attention to it though, but I'll try to recreate his. I'm guessing he's doing 15-second exposures. Let's do a wild 15-second exposure here and see what happens, guys. Of course, with me kicking my telescope mount earlier today and my polar alignment being off, 15 seconds is going to be, oh, there's 15 seconds. I thought 15 seconds would have a little bit of motion blur in it because the moon is drifting a little bit, but that looks pretty sharp and pretty decent for 15 seconds. I might have to take a still image of that. Oh, don't do 1,000 frames of that. 1,000 frames at 15 seconds each. Let's see, what do I need to do here? Moon, and I just want to do a snapshot? Is that what I want to do? I guess that's what I wanted to do. Let's see what that looks like. Ah, it has to be debared. Okay. Let's try something else then. What shall we do? I know what I want to do. I just got to figure out what tab it's under. Is the camera? Oh, you know what? My cooler's turned off. Maybe that's why we were getting those stuck hot pixels earlier. Okay. Camera format. There we go. That's what I was looking for. This window here. So I want to take it off of auto, and I want to take a TIFF file. Well, let's shoot a FITS file. What the heck? And I want to do might as well name my files. I want to do 5 frames. So now it's going to take 5 15-second exposures and save them to my hard drive. So I at least have a little record of this event. Teresa, you know, up until this point, I have not taken a single image. I've just been live streaming, but because as you can see what I had to go through to get everything going here to do the capture. If I go to this, you can see in the bottom right-hand corner the frames that it's capturing. So it's going to capture 3 more. I will have them on my website under the Lunar section. I do have to go to bed right after I'm done with this live stream, and then I have to go to work tomorrow. So within the next couple of days, they will be on my website. And my website, you ask, what is the address of my website? Well, let me show it to you. Let me call it up on another tab here. Is that ready to go to? Let's see. Yeah. So here's my website, and the address is pretty easy to remember. I live in the desert, I image the skies, and I live in the state of Nevada. So it's nevadadesertskies.com. nevadadesertskies.com. And if you go to that website, this is what you'll see. This is one of my deep sky images. And if you click on astronomy images and go to the lunar tab here, you'll see some of my lunar images from past eclipses and such. And it will be, I'll put it at the top, so it'll be like right here where this one's at. So it'll be easy to find. Look at some of my nebulas. This is my longest project to date, right here. So let me see if I can call up the specs on it. 75 hours and 40 minutes. So then you're going to ask, well, how in the world do you take 75 hours worth of exposures when there's only like at the most 12 hours of darkness in one night? Obviously this took a lot more than one night to do. The telescope tracks, and so I take individual 10-second exposures. This is called the Lobster Claw Nebula. and you can read the specs there to see. I took 30 60-second exposures from the red, green, and blue filters. This is taken with a monochrome camera, black and white camera. So that right there, just to take the red, green, and blue was 90 minutes. And then I took 233 10-minute exposures, which is 38 hours of hydrogen alpha, which is what is this sort of orangish, greenish color in this particular exposure. 126 10-minute exposures in 03, which is what brings out the blue. So yeah, it's a painstaking process. But you're free to rummage through my website there if you like. You can look at some of the other stuff that I've done. I'm not very much of a planetary imager. I don't really have the gear for that. Anyway, let's get back to the main attraction for the night. So it's done doing the 15-second exposures. So I think what I'm going to do now is I'm going to take 10-second exposures and do a little capture of that as well. Okay. So now we're taking 5 10-second exposures. Alright, so it's done taking the 5 10-second exposures. So I'm going to once again shorten down to a relatively quick exposure time so that I can easily see the movement and get it back up in that top left-hand corner. Oh, did I go the wrong way there? There we go. Now we'll go back up to, let's do 8-second exposures. Somebody said 8 seconds looked like the Death Star, so we shall see. So I'm going to do a group of 8-second exposures too and capture those. Now the vacuum cleaner is finishing, hopefully this time, or it's just so full of dog hair it has to go back to its home base and empty once again. It should get a little quieter in here. All right, so I took 5 8-second exposures. I probably will not be taking any more pictures during the partial phases. I'm pretty happy with that. I've done a lot of lunar eclipses. I have more fun doing these live streams than I do taking pictures of events like this, so that'll probably be it for the night as far as imaging goes. So we're getting kind of close to, let me see, how far away are we from the telescope doing my meridian flip. Oh, no, we still have a ways to go. Interesting. So if you look at this view here, this kind of shows the position of the moon in relation to this green line here, which is the meridian. So I'm going to advance the time on this planetarium program here and see what time it says my meridian crossing is going to be. And I'll explain why that's important to keep an eye on here in a moment when I figure out what this time is. That doesn't seem right. Okay, so right about there. So 49, 50 minutes, 12:50 a.m. Okay, 12:50 a.m. So the reason that that is so important to make note of is because the type of mount that I have with this telescope, it's called an equatorial mount. And you'll notice that I've got the telescope here that's on this side. This camera view is on the north side of the telescope itself. So the telescope is pointing to the south here where the moon's at. But you'll notice that the telescope is here, and then right here you see this bar that comes out of this side with these two black objects here. Those are counterweights. So each one of these weights weigh 22 pounds. I cannot believe that this vacuum cleaner is not finished. It had to go back to its home base and empty dog hair, and now it's coming back out again for a third run. It just won't leave me alone tonight, guys. But anyway, so the counterweights here, if I were to unlock the axis here, the telescope would stay in this position because these two 22-pound counterweights equal the weight of the telescope and the camera on this side of the mount. And that's how the telescope is able to move so smoothly and track this object across the sky. But as you will see, if it just kept going, eventually the telescope would run into the mount here, and these counterweights would be pointing up in the air. So when it gets to the point where the object reaches the meridian, which is about right here, the telescope does a flip. It's called a meridian flip. And so what will happen is everything will pause, and the telescope, the mount, will move and reverse direction to where the telescope will then be over on this side, and the counterweights will be sticking out over here on this side. So it's this type of mount, you cannot avoid a meridian flip. You just have to be aware of what's happening. And under normal conditions, I can just sit here and just let it happen on its own. I wouldn't even have to monitor it. But because of the program that I'm using to image with SharpCap here, I turn the meridian flip, the auto meridian flip off. I just kind of have to pay attention to it. Also, you'll notice coming off the back of the camera, there's a USB cable that comes out of the camera, and that goes directly into my computer, which is mounted on the other side of this pier right here. And normally the USB cable goes this way and it goes up into the mount, so I don't have to worry about it getting tangled up whenever it does this massive flip that it's going to do. But this is a USB 2 cable, so the speed of the USB 2 cable is fairly slow. And for my normal deep sky imaging, where I'm only taking like one image every 30 seconds or one image every 10 minutes, the speed doesn't really matter that much. But for the frame rate that we're trying to accomplish here, where we're doing exposures every 8 seconds, I changed it out to a USB 3 cable. But it's just running direct to the computer, and what that means is that it's just dangling there kind of loose and precariously, so I'm going to have to run out there whenever it does the meridian flip. So I'm going to really have to be paying attention to that at 12:50. In fact, so much so that I should probably set an alarm for that event. So that's sort of a long drawn out process of what a meridian flip is. Like I said, though, normally this USB cable is not just hanging loose here. That USB cable is attached here and goes up into the mount, and there's nothing that can happen during a meridian flip, because a lot of times when I'm imaging, I get everything set up at night before I go to bed, and I go to bed and I come back the next morning and the telescope is parked and ready for me to just cover it and close the roof. I don't have my roof automated just yet. That's something that's hopefully coming this April, or at least this summer. But yeah, part of the hobby. I am going to pump up the music and mute my mic once again and take a step outside to have a peek at this lovely blood moon that we're in the middle of right now. I shall return. Okay, I'm back. I think the vacuum cleaner is stuck under my chair here, trying to find its way back to its home base, and I'm hoping third time's a charm and it's actually finished for the night. I believe my exposure, as far as reality is concerned, is a little too hot. Let's go to 6 seconds. And let's see what 6 seconds looks like. 6 seconds coming in. That's probably even a little more than what I'm seeing with the naked eye outside. Let's try 5 seconds. That's a little more realistic. That's I think what I'm observing outside. The Roomba has finally made its way out of my room and is headed back to its base. I am so happy that the weather cooperated with us tonight. Boy, I tell you, 3 o'clock this afternoon when I was getting prepped for this, I was not expecting to be talking to you guys tonight. It did not look good. So here's what a 15-second exposure on my rooftop AllSkyCamera looks like right now. You can see the moon. There's a 15-second airplane trail, but you can actually make out the constellations while it's dark like this. So we're in just past max eclipse now, so you can actually see how many stars that I can make out in a 15-second exposure. All right. The winds have calmed down considerably too. You can see that little piece of Mylar film that I've got taped to the wall there is not even fluttering in the least bit. That's my makeshift windsock, so I can look at this camera view and see if it's moving, then I know it's breezy inside the observatory. It looks like my YouTube channel has yet another subscriber. Julie, welcome. If you're here because of the feed, welcome. Tell us where you're from. Furthest distance wins a prize. Oh, boy, it's getting late. All right, I think it's time for me to adjust my telescope position once again. So I'm going to reduce the exposure down to a short exposure so I can see what I'm doing here. Get this guy moved over. All right. Back up to 5-second exposures. There we go. Let's do something really crazy. Let's see. We've already done a 15-second exposure, but let's see what a 15-second exposure looks like anyway. There we go. There's 15 seconds. So we're about 7 or 8 minutes. Let's see, 12:31. What time is it here? 22. We're about 7 or 8 minutes or so away from the end of totality and the reverse partial phases will start. So let's do one more thing here. I want to do a 25-second exposure. This will be the longest exposure that I've taken, so it's clocking in at 25 seconds right now. You can see the countdown here in the bottom corner, and I'll go full screen again with it right before it finishes. Five seconds. Let's go full screen now. So this is the longest exposure that I've done. Whoa, that's really overexposed there on that left-hand side. That's unreasonable. I did like the 15-second look though. I think 15 seconds is probably what Chuck's astrophotography is doing, because his imaging was much brighter than mine. I was attempting to make, for the most part of the feed, while we were just sitting here chatting, I was attempting to make my image look sort of like visually realistic, what it would look like if you walked outside and could see it yourself. This 15-second exposure is definitely not what the naked eye sees as you walk outside to take a look at the eclipse. I think we found that 5 seconds is actually more like what you see with the human eye. Let's do some 5-second shots, and you'll see a big difference in exposure time there. Yeah. Let's split the difference and let's do 8. Somebody earlier referred to the 8-second exposure as the Death Star look, so I'm a Star Wars fan. We'll go that way. Oh, I'm sorry for yawning. We've been live streaming now for 3 hours and 10 minutes. So if you guys remember, well, you're very welcome. I'm glad I was able to bring the eclipse live to some people that are either on the wrong side of the globe at the moment or under cloud cover. Appreciate you stopping by. I was starting to wonder if anybody was actually still watching. I know there's a way to look and see how many active viewers you have, but I don't live stream often enough to know where to find that information. Oh, it says it clear, plain as day right there. 6 people are watching right now. Okay. Well, I guess I'm going to hang in there for you 6 people then. Well, I think one of those 6 is my feed. So maybe there's 5 of you guys watching. So if you remember this little clip that I showed earlier, This kind of shows the phases that we're going through here. Oh, I just lost my webcam feed of the observatory. Okay, so there's when totality started. Maximum totality, which was about 30 minutes ago, and now we're getting close to about this point right here in the feed. Eclipse totality is getting ready to end, and then if you've been with me for the full 3 hours, it's going to just do everything in reverse again, guys. Let's see. All right, let's go back to our live feed. So I think, what time do we have here? Well, if it's not over, it's about a minute away from totality being over, and we can start to see that really, really bright rim there showing sort of on the left edge there. Yeah, it's 12:30, coming up on 12:31 a.m. All right, totality is officially over. So my meridian flip that we were discussing earlier is going to happen in about 20 minutes. And I have to be honest, guys, I am so tired right now that I think that might be the end of our live stream tonight. I think I might park the telescope before the meridian flip happens. I am just worn out. I worked 14 hours yesterday. I was off today, luckily, but I work 14 hours again tomorrow, so that's going to make for a long day. Yeah, you can really see that my 8-second exposures are completely blowing out that edge there now. Gonna have to start backing these exposures down. We're doing 6-second exposures now, and even 6 seconds is blowing it out. Go down to 5. Let's just do 1 second. You can see the edge of the shadow starting to creep into view here in a 1 second exposure. This really kind of gives us an idea that totality is over. Let's bump this telescope over a little bit. It's slowly drifting. There we go. I'm going to check in on some other YouTube channels here and see. Yeah, it seems like everybody else is not going for the visually realistic look. They're going for the let's show them the blood red Death Star look. So they're overexposing their feeds, you know, which is their prerogative. They can do whatever they want. At least they're out there doing it, you know. But if you want to bounce over to Chuck's astrophotography channel, he's live streaming right now. He's got a fancy little timer going. I guess rather than have you leave me, I could just, can I do this? Yeah, I can do this. There's his channel, so you can see, you know, got a countdown clock going. He's got a lot more followers than I do. I've got, what, 500 followers, and he has 685,000 followers. But I'm not jealous. So he's got quite the chat going on his channel. And let's see, what is Nico doing here? Nebula Photos. So here's his channel. He's got a nice live feed going too. I'm not sure where he's, oh, from New Hampshire. So he's on the East Coast. Okay. Who else is doing it tonight? That's the only live streams that I'm seeing. Oh, the Griffith Observatory, if they've got clear skies on the East Coast, I mean the West Coast. Great place to visit if you're ever on the West Coast. But their telescopes are so big that they can't even show the entire whole moon in the shot. So that's a live feed from the Griffith Observatory. Back to our live feed. I do appreciate you guys sticking around with me tonight into the morning here. I'm not seeing. Oh, here's a live feed. Where is this coming? Oh, that's Reuters, but they're taking the Griffith Observatory feed. Associated Press. Associated Press has a view from Chile, Santiago. Again, I guess the overexposed look is what everybody wants. So if that's what you guys want, 2.5 seconds. Let's see, 2.5 seconds. There we go. They must be doing much longer exposures than that to be getting such blood red looks. Five seconds. Yeah, that seems to be what everybody's doing. 5-second exposures, because that's about what I'm seeing on other people's live stream feeds right now. Anybody still there? Chime in, or I may be seriously considering ending my feed here in about 10 minutes, right before the telescope does the meridian flip. If I get one person to chime in, I will stay with you guys. Well, we just had a really strong wind gust come up there. That's what that blur was that we saw a moment ago. Yeah, the wind is picking up, guys. These 5-second exposures is going to be hard to get a sharp image in this kind of wind. I'm going to step back outside and take a look at the eclipse, the ending partial phase here. I shall return in a moment. Yeah, the wind is definitely picking up out there. Let's see. We've got just a couple of minutes away from doing my meridian flip here. So what I am going to do is when that starts, it takes me about, if I really put some pep in my movement here, it takes me about 15 seconds to make it out to my observatory. So I'm going to just sit here and watch and wait for it to start, and then I'm going to take off, run, get out to the observatory to make sure that this USB 3 cable does not snag as I do the meridian flip here. So obviously you guys are going to lose image. So what I will do is I will switch over to, you can see me running like crazy to get out the building there. I will switch over to the observatory camera, and you guys can watch me act a fool as I prepare for this meridian flip. It may actually be set to go several degrees past the meridian. I don't remember my telescope settings now. Let me call that up. Sorry, block your lovely view of the eclipse. That's the wrong tab. Mount settings, that's what I'm looking for. Oh, I actually have it set to flip 10 degrees past the meridian. I think at the angle that I'm shooting, I can safely go without it hitting anything. So we might just be in luck here. And I'm gonna have to keep an eye on that in the corner of my eye to make sure that I'm ready to run out there as soon as it starts. But it doesn't look like it is going to happen at 12:50 because it is 12:50 now. Alright, let's go to some short exposures here real quick so I can move them out. See, this is right now during the partial phases. This is more like what you see with the naked eye. That's a far cry from what the exposures that we're doing. Not 5 milliseconds. 5 seconds. I've run out of things to talk about, guys. I don't know what else there is to say. It has been a very enjoyable, relaxing live stream, though. I haven't had any technical issues. Had a few glitches earlier today with some naughty USB cables not working correctly, but got that all worked out and the feed has gone well. Nice little chat with a few people. I think I'm going to go down to some shorter exposure times here, though. Get a more realistic look going. You can see that wobbling now. That's the wind. It's really starting to pick up out there. I think we're going to make it till 1 o'clock. 6 more minutes, and then I'm probably going to call it a night, guys. Well, I had mentioned early in the feed during the beginning partial phases of the eclipse that I was shooting with a camera called a ZWO 2600. It's an APS-C size sensor, so it's not a full frame sensor. But this software that I'm using, SharpCap, allows you to crop in. And you can see this little box here. So this outer white gray box is the full sensor, and we're cropping in to just this smaller area just to give us a closer up view of the moon. But I think what I'm going to do is called a region of interest. So 3496 by 3500 pixels, so almost square. I think what I'm going to do is I'm going to switch over to the full sensor. So the full sensor is 6248 by 4176. So this shows the full sensor. Let's see what a 5-second exposure looks like. It's probably going to be a little blurry with the wind that we've got out there. Well, it turned out not bad. Might have to capture that. Okay guys, it is coming up on 1 a.m. local time here in Las Vegas. As you can see, I am a little past the meridian, which happened about the meridian passing, happened a few minutes ago. Let's see what we got to do here. Yeah, we are now on the west side of the meridian. It just happened a few minutes ago. Backing up in time here. I think we're going to call it quits, guys. I do appreciate everybody joining me tonight. But I think I have got to get some sleep. Hope you enjoyed the time. I enjoyed the company. I am going to sign off. Have a good night.